Hello, my friends. We are back with Mark Russinovich, and if I read all of your titles, I think we're going to run out of time.
Yeah, you can skip that.
Let's just start with CTO, Deputy CISO, and Technical Fellow on Microsoft Azure.
Yeah.
Is there more?
No, that's it. I'm working on other ones.
Yeah.
I want to have the most ever for a Microsoft employee.
And now we're going to add the most ever Microsoft employee, Mark Russinovich. How you doing, bud?
Good. Doing good.
So tell us about the new stuff this cycle at Microsoft Ignite, things that you're excited about, things that people should know about.
Well, I mean, of course, agentic AI, I'm really excited about that, and we can talk a little bit about, especially and specifically with respect to coding, which I've been doing a lot of with agents. But I think people are hearing a lot about agents, and probably enough.
Yeah, I'm a huge fan of agents.
Yeah.
I just like the idea of having something called Agent Seth. It makes me feel more important.
Nice.
Do you have your own agent?
I don't have my own agent yet.
We'll make one.
All right.
Yeah, we'll make one, absolutely.
That'd be nice.
So what other things on Azure?
Well, I'm giving a cloud innovation session, my regular one that I've been doing for close to 10 years now.
Yeah.
This afternoon. And there's a whole bunch of really cool stuff. In fact, so much stuff, just like always, I had to cut a bunch of demos last minute just to make sure everything fits. But I've got things on servers and how we're changing server architecture in a really cool way. I'm talking about the way that software-defined networking is changing and getting more scalable. I talk about compute and the compute infrastructure and how we're changing virtualization. In fact, I'm going to introduce a new term for a new type of virtualization that we're going to be introducing, and storage acceleration, and then finally security with the Azure Managed HSM, the security coprocessors that we're putting into every server. So, and I can get into some details on some examples on each one of those, but it's just an amazing session.
So let's start with, because I'm trying to figure out a way, like as you said, virtual machines, there's new stuff in virtual machines. But I can't imagine how you could make something new on that. So please educate us.
Well, so we've had the way that we deal with hostile multi-tenancy in Azure, which means isolating customer workloads so that they don't have access to the infrastructure or to each other's workloads, is through nested virtualization, where we want to have a workload manager be able to go and deploy individual VMs or containers with this hostile code in it. And to give those workloads ability to do that, we've used nested virtualization. This is something we introduced in Windows Server, so that you can launch a hypervisor inside the virtual machine and then launch virtual machines or isolated virtual containers on top of that hypervisor.
So the question is, does time get slower though as you go down?
It does. It does. So, and actually, this was kind of cool. I showed one of the in one of my demos showing multiple layers, like VM with another VM in it, with another VM with another VM, when we first introduced this. But the challenge with that is exactly kind of what you hinted at, is that you lose performance when you do that, because now you've got 2 layers of virtualization. And you also suffer a problem that you're further away from the hardware, too.
Oh, yeah. So I was making an Inception joke
and
that happens to be real.
Yeah.
This is great. This is great. So how do we mitigate those kinds of things?
Well, so we want to treat containers as first-class citizens, and we want to give these workloads the ability to go and manage their own sub-isolation units, whether it's virtual machine or a container. So we're letting a root partition that's in a virtual machine be able to give its resources to children virtual machines by calling the core hypervisor on the server and saying, I want to take this much RAM and this many CPUs and go create another virtual machine for me that I've got control over.
So it's basically like inside of the dream within a dream, you can call the outer dream to make the inner dream manage time correctly.
Right. And now that second virtual machine, the children virtual machines or containers, isolated containers, are sitting right on top of that first layer hypervisor. So we're calling this direct virtualization.
So it's direct virtualization managed by an internal hypervisor.
That's right. And
this
so
cool
now, and there's all sorts of benefits we're going to get from this. Like, and I'm going to show, Azure Container Instance supports this. So we can launch ACI containers instead of nested the way that they're done now. We'll be launching them directly on the hypervisor, the server's hypervisor.
That's right, because I'm like the guy that's like, hey, just start my thing, and I'm just hoping it's the right thing. But there's a lot of protection that needs to happen to manage these, because someone might put a malicious thing in, and you're able to incept inside of another one the actual thing running with the hypervisor delegating things outside.
Exactly. And you'll like this one because you're working AI. Manifold, which is our infrastructure for managing our GPU capacity and deploying models onto it for training or inference, that also is now working on this direct virtualization. So the benefits there is you can take a GPU server and you can create virtual machines that are just CPU, just have access to this part of the CPUs on that. And then another one, or containers that have access to a subset of the GPUs.
Oh my gosh.
And direct access to those GPUs, which is something that with nested virtualization we weren't able to do.
You couldn't do that.
Yeah, you couldn't.
And the cool thing about that to me is that when you're training these models, like for example, with fine tuning, you need that stuff to be separate because that data is not ours, it's the customer's, and it needs to go through the GPU, and being able to do nested virtualization while have access to the hardware is amazing.
Right. And not just the GPUs, but also the InfiniBand backend network is directly accessible too. And it's cool because Manifold deploys basically a virtual machine onto the server and then doles out parts of its resources to create these containers that are running either the inference jobs or the CPU part of the infrastructure, the models. Because a lot of these models now have CPU componentry, as well as different models that make it up. And then it can say, okay, hypervisor, I've got access to these 8 GPUs, give 2 of them to this container, give 2 to that container.
Which is cool, especially because like those containers are partitioned inside of another nested virtualization, and it makes it so that you can actually schedule things in an intelligent way.
Yeah.
Which is really cool. Okay, so we talked about Azure stuff. I wanted to get into like the networking virtualization stuff, because tell me about the stack on that. Like what makes it different this time around?
Well, so one of the challenges that we've had with especially very network intensive applications that have lots of rule processing in them and maybe lots of connections is that up to now they've been restricted to either using the resources on the local server in Azure Boost, where we offload all that processing. But even that isn't sufficient for the largest scale workloads, something known as network virtual appliances, which take a lot of traffic in, do the processing on it. They're bumping the wire, and you can do SDN policies there. You can do traffic monitoring there, traffic inspection. And the way that we've done that is you create another virtual machine, and you can get this in the marketplace from third parties, my network virtual appliance virtual machine, and then route traffic from your virtual machines to that through that NVA that does this processing. Well, even that is limited by their local resources on the server, the Azure Boost, because it's just like any other VM. So we've been deploying network server appliances based with data processing units, DPUs, in them that offload all of that in a scalable way. So we can have a full rack of these DPUs. And what you can do with that is take one virtual machine and say, I want to monitor the network traffic of that virtual machine. So you route it through the DPUs. And what that does is forward it to another virtual machine that you're monitoring, your inspection virtual machine. And that's one of the demos I'm going to show. It's really cool. Is I've got 2 virtual machines talking to each other. I've got a third virtual machine that's connected to the network virtual appliance, this hardware-based one. And then I say, let's route the traffic, and then you can start to see in Wireshark the traffic coming off between those 2 other virtual machines. We do multicast that way too.
Because it's faster that way. You don't have to because otherwise it's going to the appliance and then you got to wait for it to do the thing and then go through. Multicast probably makes it so you can.
So with multicast, we can send it to the DPU and it can fan it out from there with minimal overhead. And the virtual machines on either side are not consuming any CPU.
That's pretty cool. I never, I'm the guy that's like, hey, I just want it to work. But learning about it underneath is fascinating because there's a lot of thought that goes into this stuff. Okay, so let's move on to CNCF. Last time we had a couple of projects graduate, but tell us about some of the new things that are happening and some of the other projects we talked about.
Well, so in my incubations team, we focus on cloud native incubations, and some of them that have graduated are Kata and Dapr. We've talked about those previously. And then I've got 3 incubations that are sandbox in CNCF. One of them is Kopa, one of them is Drasi, and the other one is Radius. Kopa, which is a container patching tool, we're using that to patch literally millions of container images.
As they're running?
As they're running,
As they're running?
Well, not as they're running. We patch the images, but you don't have to rebuild the whole stack of layers. So you can it's basically like hot patching for containers. And so we're patching vulnerabilities in the core OS images. We've been doing that for the last year now in Azure. Literally millions of containers get patched that way a month, and that lets us very efficiently patch our systems. But what I'm going to be showing is the next phase of this Kopa project, which is, can we patch runtimes? And so what you're going to see is me patching Python packages on the fly.
Oh my goodness! And that's like, and I said as a run, I mean like the lower the container thing that you changed, you have to rebuild the whole thing, right?
Yeah.
And so as this thing is like running, you can repatch just like a bottom layer. But you can now go even as direct to this package.
Yeah. So that's still in kind of prototype form, but I'm gonna show that in the session too, is patching some Python packages too.
That's amazing.
And then Drasi, I'm really excited about that because this is, in a world of reactive programming or event-driven programming, you want to be able to say a bunch of things are changing. When things enter a certain state, I want to know and execute this code or fire a message. And that's typically been really hard. You write a bunch of complex code that's polling things, checking things, has complex logic. Is this true and that true and this above this level and has this been above this for 5 seconds? We, with Drasi, change all that into just a simple cipher or GQL expression. You can just say, when these things are true, and that expression, when it's true, you register a reaction, which is like SignalR message or Event Hub's message or webhook or whatever. And so it really drastically simplifies event-driven programming.
That's cool.
And so I'm excited to show that.
Yeah, we saw a little bit about that last time. So let's talk about coding agents for a minute. Tell me about coding agents. How are you liking them?
Well, I've been using AI-assisted coding since the early days of GitHub Copilot, when it would do kind of the super autocomplete and then start to fill in functions. And then ChatGPT came out, and I'd go there and say, ask it to do things and copy back and forth. And I'd say my productivity boost on most projects was around 1.5, maybe 2x at the best, because I'm having to do a lot of the work myself. But agents started really coming out at the beginning of this year. And what I found immediately is my productivity level was boosted 5 to 10x easily.
Awesome.
And I've delivered some really cool projects that are just fun, and it's just totally changed the way that I program. I mean, we're really entered a new phase with agentic coding.
So I want to move on because you brought a demo. Why don't you show us what you got here?
Well, so this one,
Let's play this.
I'm doing a session with Scott Hanselman tomorrow, which is Scott and Mark Learn to Connect the Dots. It's a play on our podcast. And this is a super mega Godzilla beast, 1792 core VM. We actually created a custom task manager you see here, UX, that lets us upload a GIF and then has the cores execute so that it drives the task manager view. So each one of these is, you're seeing CPU utilization. Yeah, that's Scott Hanselman shaking his fist at the cloud.
Yes.
But that's what I'm going to show tomorrow. It's just kind of frivolous, but this machine costs literally hundreds of dollars an hour. So the video, so the demo and the work that we put in the demos is, you're looking at like $10,000 right there.
So you're doing a session with Scott. What's it on?
So we're just going to talk about the history of computing. Like, we'll go back to an Altair and talk about the different phases of computing since then, leading all the way up into this kind of super.
Oh my! Is this?
That's what we're showing.
What you're showing?
I'm just gonna go ahead and.
That's the Altair that we're.
Scooch in here.
Oh my! Okay. Did we invite this gentleman onto the? He's fixed. So okay.
Make yourself at home.
So tell us about is this your cell phone, Scott? Speaking of the history of computing.
It's my laptop.
This was Mark's first laptop.
That's a luggable. Yeah. That's a luggable.
So tell us about this session that you're doing. Well, since you're here.
This is on the Scott and Mark show.
Yeah.
Yeah. We are going to take this Altair. This is an Altair Mini. It's a replica, an Altair 8800, a replica of the machine that Bill Gates wrote 4K BASIC on. And it runs things like Zork, it runs CPM, it runs all kinds of stuff. And we're going to try to see the last 50 years of computing from Altair into to Azure, from that little thing to, my pet GIF of me in the cloud. When you look at this, do you know what's actually happening?
No, it's just blinky lights, which I like.
That is actually playing an assembly language version of Pong. That's not just blinky lights.
Okay.
If I actually,
if you may,
if I. Yeah, I gotta hit it.
We're just right.
Oh, there it is.
Oh.
I saw that bounce. You're not very good at that.
No, I'm not very good at Pong. But that's, so we're going to start with assembler, then we're going to move into basic, and we'll move into C, and we'll move our way up into the cloud. Wackiness will ensue.
Well, thank you for that. Make sure you tune in for that. Thank you for being with us, my friends.
Thank you for not giving me the right time of this event.